Okay.
So how we generally, do the data ingestion. So first thing we need to have our sources, data sources, or we can say source data or source system from where we are getting the data. What is going to be the next? Like once we know our sources, so like in your case, let's say we have had you got that file, right? Whatever file, then we have to ingest that file, right? So we are ingesting it. So ingesting means we are ingesting or extracting that file. You can say extract. The third point is going to be like where when whatever file or files or data that you have extracted. Now next is going to how you are going to where you are going to store that. So next layer of data will be storage. So it's going to be storage, and here generally storage is data lake. You know what is a data lake and warehouse? Because this is really very important to understand, because most of the people generally they don't understand this this difference. It's a very common difference. I'll tell you if you don't know, but yeah. So next layer will be like once we have stored. So why do have done this storage? Because let's say if I want to do some sort of processing, let's say now on and right now I'm having let's say 1 month data, but later my problem is not going to be solved in just 1 month of data, but just for testing I did it. Then I need to get the historical data, let's say for 1 year or two. Let me give you what we are building. We are building an application where we want to provide a retail provide recommendations or the real time data analytics for a trading company. So there right now we are having the data for 1 month, but for our deep analysis or to get the to make the better decisions, we want the data of up to last 1 year of data. So but right now, as per our subscription that we are getting the data from some source, so they are on the current subscription they are only allowing us to get the data for last 1 month or 28 days or 30 days of data that we can extract. And that 38 to 28 days are basically those are the trading days, not the Saturday Sundays or some public holidays are not going to be included, where on that day where the trading is not happening, right? So the thing is he basically, so we have to get, as the more data is going to be there, so we will be able to get the more insight from the data, and the decisions that we are going to take are going to be concrete ones. So that's why big data is why we are doing that, a lot of efforts in storing and processing that huge amount of data. So when we are having huge data, so definitely the final outcomes which will come, those are going to be more uh, you know uh, more concrete, right? So next, once we have done the storage, then comes the processing. This is one of the most important part, that although all the steps are important, but this is where we are generally going to write some code, right? The coding we have to done. So coding processing means we are doing some sort of transformations here. So we say these are transformations. Then after transformation, what will my step? It's going to be basically, once we have done, so we are going to store our final tables wherever we want. Like here in this case, it is going to be Databricks. Let's say gold tables are going to be there, which are going to be my final finished product. So those are going to be for serving. Serving means like here you can say for different teams, like ML, AI, ML team, AI team, or we can say analysts, or many more, because there are going to be many more. Even within the team itself, many teams, they consume our data, right? Whatever data we are providing. And final thing that we have to do is so whatever we have developed, we have to monitor it and optimize it, because this is again going to be a very important monitoring and optimizing.
What we do in this serving ML and AI?
Serving is basically like we have here we have provided our finished tables. Like after doing all the
Okay.
transformations, whatever I'm going to give. Okay, this is my final table. So that table data is going to be consumed or read by some other tables. Why we? Because the task of what is the main task of a data engineer? The task of a data engineer to make available data in the format, in the way the user requires it, right?
Mm-hmm.
So once that will be there, because once we have given the data in the format they need it, then they are going to use it. So serving means users, basically those who are going to use that data. So that can be your machine learning team, that this can be your AI team, that these can be your analyst, or those can be your different team members who are going to utilize this data, right? So why we are doing all this? Because the business leaders or the managers, they need that data to build some sort of reportings. So there are n number of reportings generally that happens. So basically, management doesn't need to know like how you have done it. So they all only need that reporting purpose, for their reporting purpose, whatever data they want. So we are the one who we basically provide that data to them, so that they can build those reports and they can perform what kind of operations they want to perform on that to get the inside of the data, right?
Mm-hmm.
So this is our main task. Like we have to provide the data in the way or in the format they want, what structure they want. So this is our main task. Then comes the monitoring and optimization, as I told you. So for monitoring, we can apply different sort of alerts, or either we can do it on Slack, we can do it on Teams, we can do it on emails, different alerts at different levels. So at and those alerts are going to be we can fix them, like if wherever there is going to be a failure is going to be there, or like even on the warnings also, if you want to put it. But sometimes like it's not going to be the code which has actually made some warnings. There can be some back-end issues, or even the infrastructure issues are there. So generally we don't put the alerts on in case when we are going for the warnings itself. Otherwise, like every time your phone or your Teams will always be pinging every time. Okay, so generally in most of the cases, like I never seen like we are going to put, but if you want, like you can put the on warnings also instead of going for failure, but that really going to create your issues. Like every time it will ping you, okay, this is the warning, this is the warning. So warnings can be there, but error can is going to be happen only when something has happened, bad has happened, or something is not working properly. So in that case, and another is the optimization. This is another very important point, because nowadays, like most of the organizations, they are mainly working on, they have those who have already built their systems, they are mainly working on this optimization part, because most of the cost that we are is going to be uh, invested in terms of the resources that we are using. So to minimize this cost, or so we have to do the optimizations. So as I told you earlier, maybe I don't know whether I have given this context. Like even in Databricks, here we, based on the query, we were using a very huge query, some few thousands, words of queries are there that we were using, and it was taking around 34 minutes to run. So it was spinning the cluster, and it was consuming very lot of compute power, and it runs every 1 hour. So every 1 hour, so you can think about, like, every 1 hour we have to run a job, and within that job one query is taking around 34 minutes, and the rest all other, let's say there were 20 different queries were there, so total time consumed is around 40 to 45 minutes, but just one query is taking that longer time. So it was really costing a lot to the organization. So around 100 to it was taking around costing around 100 to 120 pounds per day. That's one job was taking. So within our organization, we have got more than thousands of jobs are there, and if every job is taking, we are not saying every, but even if two jobs are taking that much amount of time, so that is going to create a lot of issues. So I was the part of that. Not the part. Basically, I was basically leading that one. So what we did is, like, we have minimized that query optimization to 8 minutes. So now you can think, when previously the cluster was spinning for around 40 to 45 minutes, now it's able to do it in 10 to 12 minutes total, full job. So, and this query is reduced from 34 to 35 minutes, from 35 minutes to 7 to 8 minutes. So when we have analyzed this over a month, so we found out that it was saving around more than 12,000, total 12,000 pounds a month. So you can think about, like, this much amount of cost you can save by just optimizing the things. So that's why this optimization plays a very crucial role. Okay, now if you have any idea, like, can you just tell me, guys, what is a data lake? There are few things like data lake, and data warehouse.
Data lake is the local storage repository for raw data,
Yes.
like structured, semi-structured, unstructured data can be stored in data lake. Whereas data where you ask data warehouse, what is the difference between data lake? Then what is the question?
Data lake, and data warehouse.
For data warehouse is structured repository, and then uh, it delta lake. I have no idea. Is that correct?
Yeah, you are correct actually. You're almost means you have got the idea actually. Yes, what about you? Yes, are you there? Yes, she's not there in the call.
Um, yes, he is here, but he is on mute.
Okay. So, so basically, what I was telling you, like, yeah, a data lake. Basically, previously, before data lake, we have the concept of this data warehouse, right? So, data warehouse
Mhm.
only have the data in structured format, and it is basically, it is an optimized, structured data store where we are basically putting the process data, right? And
Right.
generally used for business use only, like
Mhm.
different teams are doing a lot of they are applying some business intelligence on top of this uh, data warehouse. So basically the thing is, like, when we are dealing with not dealing with huge amount of data, so basically it has got a lot of cost associated with it. So because here we have to maintain the process data, which is having huge amount of volume, although it is going to be in raw format, but we have to do it. Another issue, so this is going to be the the cost which incurred. And another point, that we are not able to process unstructured data. Like, we cannot store unstructured data or process unstructured data with the help of warehouse. So warehouse is only meant for structured data sets. But now, as we know that with the introduction of this, so now 90% of the data that is getting created, that is coming in the form of unstructured format only, whether in the form of raw text that we are getting, human readable text, audio, video, images, the data which is coming from the streaming, it's coming in JSON format, which is semi structured format are there, or the data we are getting in XML format. So these kind of formats, basically, it was difficult to process. Even unstructured data it cannot process, but yeah, we can process some sort of semi structured data using warehouses. So that's why uh, it was having the issue. So what has happened then? Then comes the concept of data lake. So data lake is what? It just a it's a object storage. Like, we have got, if we talk about the normal uh, the starting point of any data lake was the HDFS, that's Hadoop distributed file system, right? Within the Hadoop itself, the HDFS is a data lake where we are dumping each and every file. We are not under taking care of whether it is going to be structured, semi-structured, or unstructured. Any kind of data, we are just dumping into the Lakehouse. So the storage is going to be cheaper. So if we talk about any of the cloud providers, so you can see, if we talk about AWS, so S3, which is called the cheapest storage. So we are going to just put and dump it into the S3. Same for if we talk about Azure, so we have got ADLS Gen 2, and for uh, Google, we have got GCS, Google Cloud Storage, GCS, Google Cloud Storage. And again, these are all object storages are there where we can put our data. Then comes the which we call Delta Lake. On top of this, we have built, or this is called Lakehouse architecture, which is our Databricks. So Databricks stores the data in the form of Delta Lake, Delta format, or Delta tables. Tables is different, but format is Delta. So basically, what is Delta format? It's basically the the combination of both, right? Because warehouse, we have got these ACID transactions are there, ACID properties are there. At runtime, we can update it, atomicity, consistency, isolation, and durability, which are ACID generally apply on our transactions. So if any of these ACID properties is not fulfilling, so my transaction doesn't complete. So those ACID compliant things were there as a part of our data warehouse, but in data lake, it's just the storage. And in data lake, we are going to store by default storage is the Parquet format, which is again very optimized, and columnar format is there, which reduces the cost, as well as it helps in optimizing, or optimizes the process itself.
So in Delta Lake, we can store only Parquet format.
No, this is the default format. Although like when we are going to store the data, and if we are going to store it in the Parquet format, so it is a columnar optimized format is there. But it doesn't mean like in S3, whatever format of files which is coming, you can store it, because it's just a store. Like you have a store, like in the store itself, you don't you are not going to put the data in any of the uh, basically format, or you are not doing any sort of sorting kind of thing. You are just dumping it. So my data lake is just a you can say simple storage is there, but within the warehouse, if you see, it's going to be organized way, right? So in data lake, data is not organized at all. We are bringing the data, putting it, then we are doing the transformation. But within the data lake itself, so it's a combination of both. It's taking the power of both, which is the cheat
So
code.
Delta Lake is the combination of both data and lake and data warehouse.
Yes. It's called data. Now the concept is data lakehouse architecture. So basically, it's a uh, lake from the data, and warehouse house from the warehouse. So it's a lake warehouse. Now we call it as data lakehouse architecture, which is
Lake
our
Lake house.
it's data
Okay.
lakehouse, right? Which combines the the power. Like what is my data lake? It's the cheapest storage with the performance of what we are having as a part of data warehouse, right? So warehouse plus lake. So it's lake house architecture. So this
Okay.
Databricks is
A
basically
warehouse plus data lake, it's a data lake house.
yes. But apart from this, these this Databricks has come up with more of the more options. Like I have shown you in the last video also, like last session, where we are having these lineage history. So if we want to go back and let's say I want to see like what was the state of my table or data, let's say 1 month back, so I can go and get that data also. We have got the this time travel facility available as a part of this. Apart from this, we have got Unity catalog, which have got centralized server authentication, giving the access to whom, and as well as these kind of facilities.
Mhm.
So catalog. So here we have got these, history. We can get it. Or lineage is there. So these new features has been implemented as a part of this, lake house architecture, right?
Mm.
Okay, fine. So let me just I'll share this notebook with you.
Okay.
choose my menu estimate. This is just a, like how we are going to read a file, read a table. So generally, if we are going to read our file, so my syntax is going to be catalog name dot schema name and my table name, right? So as I told you, like this is my by default a Python notebook. So whenever you are creating any of the notebooks, so it will always going to be default in the language called Python. But if you want to change it, so you can change it from here itself. In this, you will only see two options, as I told you. But in when you are going to do it with the paid version, so we'll see two more options are going to be there, which is Scala and R. So those two,
Okay.
yeah.
So
Hmm.
I have a question. So here, you directly come to this notebook, right? I wanted to ingest the data and see how it is coming under the catalog and how we take the catalog name.
Okay, so I think last time I told you this thing. So if you want to create the catalog, so you can, there are different ways. If you want to create it like this, so you can just go to catalog here, and
Okay.
you can also create, go and create the catalog from the workspace itself. Another way is go to the notebook. You can just write.
Catalog is just we are creating the name, or are we going to insert any
It's, no,
files
no,
in it?
it's just creating the name. Catalog as well as like catalog, you can take it as a, the top level folder. Within one catalog, we can have multiple, schemas can be there. So schema, you can take it as a database. So within that database, you are going to create those tables, right?
Mm-hmm.
So this is my catalog. Within that catalog, I can just, let's say, this is my. So let me create.
Yes, you showed this, but I don't get it. But catalog and then schema.
Within schema, you can create, multiple volumes and the tables, views, those things you can create. So there are different ways of creating them. You can just go and do the.
So this is the initially I showed you, right, that tables and volumes that comes under here, right? Whatever tables we are I mean ingested will comes under the table, and then the volumes will becomes under the volumes, right?
This is the default, uh, this is not the only where we have to put our volumes, right? Here within the Databricks itself, we have got, DBFS. There's a distributed, Databricks file system is there, which is Databricks default one is there. But apart from this, if you see here, they are, if you want to upload the data, so we have got lot of options are there, right? So
Mm-hmm.
these like Amazon S3 is there. So if you have got, you can create your, uh, account on Amazon, and there you can put your files and you can read those files from Amazon because it's the cheapest, storage is there. Because if you want your data is going to become in terabytes, petabytes. So storing that data, if you can store that data in DBFS also. But DBFS again,
How we consider if we are going to, how we take this one, if it is the Salesforce data, we are going to put it in Salesforce. If it is from,
so
if,
you just need to get this whatever you need to create the connections to the source itself. So you are going to get the connection name that are authenticated. Once you have done it, so from the source itself, you can get this data into your Salesforce, and then you need to write some code to get.
oh, if it is coming from the Salesforce, we do connections from the Salesforce directly here, and then we are getting the data from there,
Yes,
right?
and then
It's
you
kind
can.
of live streaming data,
It's both. Like if you are getting the streaming data, then you have
or
to
it's
use.
from the
Yeah, yeah,
website, anything.
yeah. You can use like Kinesis. You can use even Kinesis is basically AWS. Services there. But if you want to use another, let's say you can use Kafka also, right? So
Kafka
it
is for
all
what?
depends on. Come again.
Kafka is for what?
It's reading the real time data.
Okay. So here you told me in the last section there is one cloud something, I forget the name. It's for live streaming data where it is available
Yes.
in Databricks itself.
Yes. So like you can get it, but to streamline the data, to get the data into the system, you need some sort of medium. So basically Kafka is having these APIs which basically used to consume that streaming data. So basically with the help of Kafka or Kinesis, what we get is like we are getting the data in the from the source in JSON format, and then we are going to bring that data from source to your let's say S3. We are storing it in the S3. There you need to build a process, right? So for
Mm-hmm.
building that process and ingesting that streaming data, we either need Kafka, Kinesis, or in Azure we have got Azure Event Hub, right? So
Mm-hmm.
different providers provide their own APIs or
What are those frameworks or tools? Kafka and then Archines, what is it? What is
Kafka. We have got AWS Kinesis, and from Azure, it's Event Hub. And if we talk about GCP, it's PubSub services there, public subscriber model is there, which basically we and everything it's coming in the form of topics. Like in Kafka, for each topic we are going to get the similar kind of data. So we define their topics so that on real time we are getting the data. So like these are the basically the ingestion types that you are talking about, right? One is my
yeah.
batch mode, another one is the streaming mode is there. Batch mode is there, like we are going to consume the data in the form of batches. Like we have defined the batch. Okay, every 1 hour my job is going to run. If my data is coming in that way, the frequency is that I can get the data in let's say once a day. I can get the data weekly. I can get the data every 10 minutes, 20 minutes, 30 minutes. But generally this 10 minutes, 20 minutes, 30 minutes, we generally do it for the streaming data. And if my data is flowing very fast, let's say some transactional data is coming, let's say for my project, if I talk about, it's a partial delivery domain organization is there. So all over the world, if we see like within a minute also, like we are getting thousands of the parcels are going, data is coming. So every 1 minute, you see, every 1 minute we are
Mm-hmm.
getting few hundred records every 1 minute. So we have put that the limit, like every 1 minute we are fetching the data. We have every 1 minute whatever data is coming from the streaming Kinesis stream, we are fetching that data and putting into our data lake, right? So this is how we do it. So based on the it's all based on the organization to organization, that how we are going to what is the frequency of the data that we are getting. Some organizations which doesn't have that data, they are getting the streaming data, but still they are keeping the window of 30 minutes, some keeping the window of 5 minutes, some keeping the window of 10 minutes. So it all depends. Just let me tell you one more, like right now what we are working on it. So we are having a streaming job which is running simultaneously for 24 hours, 24 cross 7. But what is happening is now we have find it out, like after 6 o'clock UK time, and in the morning before 9, we are not getting any data. So for, you can think about, for that period of time, like after 6 to 6, so for almost within 24 hours, for almost 15 hours, we are not getting any data. But our cluster is spinning at that point of time also. So for those 15 hours on daily basis, my resources are getting waste. So this comes under the optimization. So how we are going to do this? But we have to have this pipeline as streaming also, because we are getting, for that period of time we are going to get. So there are different multiple options are there. On day before yesterday only, I just get to know from one of my developer that he's facing this issue, he has got assigned this task. So I just basically told him that how we can do that. So that multiple ways that we can utilize this to get the correct form of, like how we can utilize this. So either we can create the window of let's say either we can fix it that during this period of time we know that okay, after 6, so we can put it at, let's say, 6:15. After 6:15 automatically my compute is going to be stopped, because we don't have to do it manually. And we know that in the morning the data is going to become at 9 o'clock, so we can put it as 8:45. My compute will start automatically. This is one way of doing it. Another way, we can do it like whenever a file is arrived, like this is called file arrival time. So if my file is arrived, automatically my system is going to be start the compute and pick that data and process it. This is another way of doing it. So there are different ways we can use them. So
I think anywhere in this free edition we can we can see the how the live streaming can be connected and how it is come. Any ways you can show us so that I can have an idea.
for streaming data, we'll see, like okay, we'll do one session on that.
Okay.
We have to set either we can do it with the Kafka, or we can do it with the help of Kinesis also, or Event Hub, because that those things will, okay, yeah, we'll do that
Okay.
yeah, when we are going for the streaming data itself, right?
Okay.
Yeah.
So coming again to the point, we see catalog. Catalog is the initial, is just the name, right?
Yeah,
And
this is just
then
the name.
top folder you said, and then the schema, and then schema comes down to the catalog. It's a database. It is again the name. It's again the name, or
You can give any name. I just giving it my generally catalog name remains as catalog only. Within the catalog itself, we can create multiple schemas we can have, right?
okay.
So there are different ways, like you can go to the catalog, and from there itself you can create a new catalog, and
Then
within that catalog you can create the your schema. And once you have create the schema, so within that schema either you can create the tables manually, or you can create the tables from the data itself, right? This is how we generally do it.
okay, how we create the table there itself, right click and create a table, and then adding the table there, or how we do that?
See, either like if you have to create a table here itself, right?
Mm-hmm.
So within my schema, one way is like these tables I have created using the the data, using the data itself, like reading the table itself, data, and from that data I'm creating the table. Let me show you that.
Is this the table already available, or you
No,
have
no, no, no.
created?
Table was not available for this one. I have, because this, if you see my volume, this is my, in my volume I am having this baby names beginning 2007 data set, right? From this data set I have created these table.
Okay, okay, stop here. So how you get this inside? How you bring this data inside first? This
Yes,
test data.
exactly. Within this test volume you are saying, right?
Yes.
So I am having this file. I have just, let's say, downloaded this file from somewhere, or from where I'm getting this file. I'm having
Mm-hmm.
this file in my system.
Okay.
So here we are just doing it, manually, right? But in our system also, like in real ingestions, even these files are coming via some, from the source itself. So for that, some system is there, like in some, let's say if the data is coming from a SharePoint folder itself. So somebody's either dumping that file on daily basis or hourly basis, whatever the, the frequency is there. Then if we have created, the pipeline, so as I told you, there is one more, a concept, or the process is there, which is called autoloader in Databricks. So autoloader basically works for both streaming as well as, batch pipelines. So within autoloader, we have got one functionality is there, which is called as file arrival. You know, so it notifies that whenever a file is coming, so it takes that file and bring it into the system itself, right? This is automate. This is how we do the automation, and this thing we can also do it with the help of, writing the code itself, because that is already been given, so we don't need to write the code. But if you want to, because whatever we are having as a services, we can utilize them directly as well, so we don't need to write any code. But when we are writing the code, so we have got the, more control, more manageable things are there, right? But
Mm-hmm.
if we are utilizing the already, software as a service, so there we don't have the, that leverage that we can modify it as per our requirement, right?
Okay. So let's go step by step. You can, as you said, here we are using on-premise data.
Yes,
So
yes, yes.
uh,
Go
and
to
then
file.
we can, using autoloader kind of thing, we can get streaming data as well inside, right?
Yes,
So
yes, both.
let's see first that on-premise from the, I mean, from your laptop, how you're getting.
Yeah, we'll see all those things. Yes,
Mm.
that's why I told you. Like most of the things, like because Databricks has got, all the things are there. Like whatever different providers are providing, so they have just, combined each and everything within this Databricks itself. So if you understood the Databricks, so you don't need to go to anywhere else. That's why most of the, even I'm trying to put whatever I have learned so far, whatever I'm working so far, I'll try to put everything in, within it itself, right? So
Mhm.
what you are going to do is upload files to your volume. So when you go here, it will ask,
Mm.
like as I told you, maximum to 20,000 files or max size of 5 GB. You can just put it in any of the volumes. So
Okay.
you can browse your file or folders, whatever you want. Like if you have got multiple files are there within the folder, you can also select the folder itself, right?
Mm-hmm.
Go to files, any files, let's say I'm just doing it. It's a documented file, but just to show you how we are, and I just wanted to put it in my test volume and upload it. Now you can see this file has been uploaded successfully because it's showing us green color. And if we go and check this within my test volume, so you will see we are having this file also,
Uh,
right? Spot errors, just uploaded 14 seconds back, right? This way you can just upload your files, or when you are uploading it, you can create your own. It will ask like if you want to select on the existing one, or if you want to create a new volume. Or once you are here, let's say you can also upload directly from here itself. So it will directly, now it will not ask you to, because we are uploading to this volume, right? But if you are going from here itself, so it will ask you to upload to which volume you want to upload, or you want to create a new volume. So here, if you want, you can just click on this, create a new volume, and upload your file, right?
Okay.
And also volume types, as I told you, there are two types. As we have got the table types are there. Managed volume, which is again the location is going to be Unity catalog. But if you want to do it externally, you can specify, apart from, so this Unity catalog manages DBFS basically. And now apart from this, everything is going to be your external. So external is going to be, applicable where, or when we want, like if you are dropping anything from the, let's say if we drop the table itself.
You please explain that Unity catalog and then the external one. I don't
So yeah,
get that.
Unity catalogs has got, it's a centralized, we have already discussed this thing, but yeah, within the Unity catalog, you can create, schemas, and within schemas, you can create volumes, you can create tables, you can create, views. So here, as I told you, these tables I have created, not using the, create table schema. I have created these with the help of data itself, right? So I'll show you how I have created it. But from here itself, if you want, you can also, add data, create volumes, create a catalog, right? If you want to create a catalog, you just go and create a catalog, and you want to create any external location, so you can do that. Then within the catalog itself, then you can create any schema itself, right?
Mhm. So what is that Unity catalog? Is you created anything here, Unity catalog?
Come again, please.
So if we create catalog, everything comes under Unity catalog. This
Yes,
external
yes,
catalog
yes,
is
yes,
different.
yes. Basically, yeah. What happens is, like, when you, because Unity catalog was introduced 4 to 5 years back. So basically, what happens initially, like we have got, workspaces here. So we used to have multiple workspaces. Like one team is, let's say, data engineering, another team is AI ML team, one are another, let's say, some analysts are there. So they used to have their own, different workspaces are there. So within the workspaces itself, we used to create this, databases, and databases, we used to create tables, views, all those things, right? So what happens is, like, when one workspace need to access to another workspace, like I wanted to access from table X from workspace 1 in workspace Y. So we have to do lot of, inter workspace connections, and it was very difficult and tedious to handle all those things. So there was no centralized governance was there, right? So with the introduction of this Unity catalog, so this has become a centralized server. So irrespective of how many number of, workspaces are there within the organization, every organization can access those tables whosoever want. But based on that, like, everybody cannot access every table, because whosoever is the owner of that table, that defines the access controls. So it is basically a centralized governance tool is there, which basically give the access to which level that particular user or group can access that table, right? Let's say I have the owner of that table, so I am the admin, so I can create it, delete it, update it, whatever. But if you just wanted to read that data, so I'll provide you only the read permissions on that table. If you want to modify it, you are not, you cannot do that, right? Because I have not given you that permissions, right? So that's why this Unity catalog plays a very vital role. Apart from this, as I told you, this has come up with a lot of other features like time travel. If I deleted my table, let's say deleted the data, not the table, I have deleted the data. Even though if you have deleted the data, now we have got we can undelete the drop. If even if I have dropped the table, I can undrop the table itself within a span of time, right?
Mhm.
Previously, if my my table got deleted, so it's got deleted. Although like if my data was there in some external location, so I can create the table from that location, my data is intact. But if my data
So,
is
so what I understand from your saying is like Unity catalog is it connects all the workspaces, and then we are taking the copy and working from it, and then if
no,
there
no,
is
no,
any no.
exactly, you don't need to take the copy, you can directly work on it, right? It's all
Okay.
the so
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 okay.
this is what I was trying to say. Now you don't have to have previously we used to have same tables in multiple workspaces. So that
Mhm.
was also a confusion. Like uh, if I have to, let's say I have got the table X in workspace one, then I have to, and the table X I can have in workspace two also, right? With different data sets and all. So if we have to go and get the correct path for that file for which we have to work upon, but now this is centralized catalog is there. Here you don't for different workspaces you don't have the
Okay, so what are the modification is we are doing, it is being stored, and then we can again retrieve it whenever we want going to that particular step. So that is how it works, right?
yes.
So it is actually basically the Unity catalog is the connection of workspaces.
Yes, now it's basically it's a centralized one, right? So this
Mm-hmm.
is central to every workspace that we are creating, or the so within the, as I told you, within one uh, catalog, we can have n number of uh, schemas can be there, right? So you don't like for different teams, they are not creating different workspaces. Now they are creating different schemas, right? So
Mm-hmm.
they can work on their own, schemas itself. And if cross teams need access to those schemas, so only like we can provide the permissions based on catalog, schema, table label, view label, or volume label. So that at each level we can provide the permissions to access those files. So this is how we do, right?
Okay.
So
Okay. So
yeah,
catalog and then schema, table, volume. Okay. So okay, this is how we bring the volume inside.
yes. Okay, so I was just go to this file revenue stream. So just wanted to show you, let's say this is how we generally like, if I just truncated my data. So I've truncated my data, and if I want to restore it, so I can do it with the help of this is called time travel. So if you want to go to the previous version, I can specify with the version as of or with the help of timestamp, because my whatever table I am having, let me table. So you see history. This is very important, and very usable feature. Like if we deleted the data from the table itself, so we can get it.
Mm-hmm.
So first two columns are there, version or timestamp. So based on this, we can time travel to any of the the previous versions we want, because latest
Okay.
versions always be there. But if you want to go and check your previous version, or even when you are uh, doing the queries, if you want to check what is my current version, what is my previous version, so you can also use version as of and timestamp as of, right? So
Okay.
if you want, if I want to get this version like when I've created it first time, so I can get those, either like version as of 0, version as of 1, 2, 3, whatever the versions are there, and we can do that, right?
Mm-hmm.
So this is the command to restore table name, and version as of, right? So this way we can do it. So you can try out all these, very very important and commands. Then this is, if you want, you can just go and check some of the dutil commands. So these are Databricks utility commands are there. With the help, you can just go and check. So, like, generally the most of the times that you can use is file system files. So this will gives you the what are the file structures are there, in which folder, how many files are there. So you can just go and check to, like, if I wanted to check this Databricks dataset, so we have got COVID. So if you go and check to this particular location, you will see these are already given data sets are there. So you don't, if you want to do some sort of hands on these already given data sets, so you can do that, right? Amazon, airlines, adults, so there a number of data sets are there. So then I think last time also I just told you uh, how we are going to create the data frames. Simple. If we have got data, we have got, like, this is what I'm having the data. So instead of having this, we have done it manually. We can just get the data from the file itself, right? Directly we can get the file, and then we can specify the schema, or on if we know like what data that this is having, and then we can create the data frame on top of it. So we can specify data and schema. If I'm not going to specify this, also just put columns, so that will also work. And then I'm filtering the data based on wherever the age is less than 10, and then I'm just getting the distinct on it. So you see, so first it will give us what is our initial data frame was there. So data frame is, as I told you, just a you know uh, data structure on which is built on top of our RDDs, but it is in the form of row and columns. So it is easy to maintain, easy, and have got a lot of optimizations involved in it. So you see, we have got these 5 records are there, and then what is our second statement? We are just getting those ages where the age is less than 8, so less than 10. So we are only having one record, right? So that's why we are getting this. And the third one is, yeah, so on children's only, We are not applying on filter because, as I told you, this data frames are immutable, right? See?
Mhm.
So every time we are creating a data frame, it is creating a new record, basically new file on top of it. New data frame is going to be created. So that's why they are called immutable. So we are just getting the distinct. So all our distincts are. That's why we are just getting. The, then what we are doing is now. This is another pandas library is there, so we can read with the help of pandas also. Like it's we are calling pd dot read excel. Otherwise, directly if we want to read any excel file, so we don't have any uh, uh, in Spark, we don't have any direct library from which we can read the Excel file. So what we used to do is we used to create some function, and then we are going to call that function to read the Excel files. But now in Pandas, they have come up with direct read function. So pd.read Excel, we are reading it. Apart from this, all the functions like we can read CSV, we can read JSON, we can read Parquet, we can read RC, ORC, or other file formats. But for reading the Excel, there was no direct method was available. But now Pandas has come up with this functionality.
So we are ingesting the data by tabular format, and then in the volume, we are doing it there. Apart from that, what you are showing is we are directly reading from the code.
Right.
But
So
right,
from the file
Python.
itself, we are creating the this data frame, right? So now we are not doing anything. We are just reading this file, revenue estimates dot Excel file, in this pandas data frame, and then this pandas data frame, we are creating another data frame called df Excel, right? And we are just displaying it. We have not done anything. We are just reading a file which is Excel file into a.
We are not ingesting, we're just reading.
Yeah, we are just reading it. So ingesting means like definitely it's read, because this file is there in my within this my folder, my files volume is there. From that file, this file exists in resides in this folder, right? So there this file is there, but I have not created any table out of it, right? Then
Mhm.
on this file, I'm just doing some transformation. I'm just finding out all records where the average, revenue average is greater than 1,000. So if you see total, we have got 179 rows are there, and average revenue is somehow, in some cases, it's also negative, right? Some negatives are there, but generally it does should not happen. But yeah, we have got negative in most of the cases. Revenue doesn't should be positive only. So that's why here we are all the records are having negative values, no positive values. So that's why this is filtering out all those records. So this is just simple filter statement is there. What we are doing is here we are reading from Excel data frame, selecting star means all. So here we are selecting all the columns. But if you want, you can just select few columns by comma separated list, right? And then do the filtering on it.
Mhm.
I'm doing, let's say, less than zero itself. Now, what it is saying?
Revenue average less than
Not
0.
defined, right? Why it is saying not defined? Because we have not run the above cells. Because this we have not created any table. It was just the and if I even if I'm going to run this, it will give me an error. because first we have to install this open Excel library where this Excel read Excel function has been defined, which is coming from the pandas Excel. So first we have to install this library, right? Here we are installing it manually, like within the code itself, but again, this is not a good practice. So when we are going to create the cluster itself, right? Here we are using serverless, and within serverless we are not supposed to do anything. So that's why we are just installing it live. So every time we are going to run this, so we have to install this library. When we are going to create our own cluster, there within the cluster itself we can install these libraries. So every time when the cluster is going to spin, so before starting whatever libraries it required, or we have asked for the installation, first those libraries are going to be installed, and then we'll do the processing, right? This is how we do it. Now it will work because now it has got all the required libraries are there. We got it, and now it will work, and it will give all the records. I think 179 all are having negative values, so we got all 179 records, right? Then once we have got the final output, right, now what we are doing is we have created a table named revenue estimates, and we are doing what was my final frame was there, df transform, which is having these values. And now we are going to write it. Format we have defined as delta format. So this is when we are going, although if we are not going to define this format as delta format, in Databricks, this is the default format the table is going to be created. Then what is going to be my mode, like override. So override means like every time it will clean the data and writing the table again. If we want, like, my data is going to become in the form of append mode, like incremental data is coming every day, my some data is coming, so there I have to put it as append mode. So they are different, like override mode, append mode is there, right? And then save as table, and I'm specifying my table name. If you want, you can directly specify this name here itself, right? But we are doing it using the variables, so that if like here we are just specifying all those names, but in real scenario these table names and all, we have to do it from the config itself. Like we are going to create the configuration, and within the configuration itself, every time we don't have to change the code. Only thing, we are going to pass the configurations, and those changes are going to be applied here. Now my table has been created. So here in the next cell, I can check here itself. So let's start from my table name. So my catalog, see, it's always come my schema dot revenue estimate. Spelling mistakes. Run it. So it will give me all those 179 records. Syntax error near the, oh, it should not be dot. Mistakenly, it should be semicolon. Okay. Why? because this is, I'm just creating the table with the table name, right? Because this table is going to be, it's not created in the schema itself because we have not given the correct schema name. So we have to specify this as well to get the table created in the schema itself. See, so this is one way like how we are going to create the table. Uh, this was the for the Excel. Same if we have to do it for reading the file from the, let's say, CSV itself. So here you can see within the Spark itself we have got direct function is there, read function. So spark dot read dot format, or we can also write spark dot read dot CSV also. We don't have to specify format, but this format will work for all the different formats. So generally we used to it's all depends on if we directly want to read it, so we can read it spark dot read dot CSV, and then we can specify the the file path. But when we have to have more control, like we have to specify options, so within the options there are different multiple options that you can find out. You can go and check Spark CSV read options are there, then you will get to know different options. Spark CSV read options, right? So what are different options? So you can just check out. So here you can see these are all the like options are there: Parquet files, ORC, JSON, CSV, text file, XML. You can check out all the different formats are there. So either you want to go for Scala, Java, Python. So we are doing it for Java, Python. So you see spark.read CSV, and then we have got the path. So it's directly if we have to read it direct from the path itself. But path basically gives you some of the other options, like you can use option as delimiter, so what is the delimiter in your file path is there, then you can change that delimiter. Header, another one is the header, whether you want to take the header as true, means like whatever the headers that has been specified, so those are going to be the part of your column names, right? So there are different, options are there that you can take it as part of this. So here, so when we are, within the delta table itself, like this is the first name is there, right? So these spaces are not allowed. So we have to, rename it. So the name should be just, within the naming itself, underscores are allowed. So if first name, last name, or some those kind of, like, so my name is Raj Kumar. So Raj and Kumar, I have to put it, it should be Raj underscore Kumar. It's a column name only, not the value part I'm talking about. So like first name should be first underscore name. It will give an error if I'm not going to rename it, right? So for renaming, there are again multiple ways are there. One is like with the column renamed. This is again, predefined function is there within the Spark itself. So names with column rename. So if you want to rename multiple names, dot with column with column with column, you can do it. Or another way is like you can define a function to rename a column, or formatting the column. You can create any function which is replacing your space with underscore, and then before using that function, you can call that function, and then within the without with this with column rename, you don't have to do it, because that will help you, like let's say within your whole script, that function you have to use multiple times. Or let's say your columns are, let's say 100 columns are there, so every time, every day, every time you don't have to do it, and this is in one file. If you have got such 10 files are there where you have, because we are going to work with multiple files, and you have to so to avoid this, rewriting the same code again and again, we can create a simple function to, rename the columns, or just removing the special characters from the name and replacing it with underscore. So that will be easier way. Then once we have renamed it, then we are just transforming. Otherwise, like if you are not doing it, so if I'm going to remove this and run this, so this is basically, it will give me when it is writing the file, because when it is writing the file, so it suppose that the file name should not have any space characters within them, right? Next, we are just filtering them wherever the year was 2007 and above. Then we are selecting all again. If it all depends on the requirement, like whether let's say from the input file or input data, we are having 100 columns are there, but in my finished final table, I just wanted to have 20, 30, 50, 40 likewise. So I have to get all those columns here itself, instead of, so here we don't have, we are just having 5 columns, so we are just adding all the columns to my final table. And then I'm specifying my table name as catalog name dot schema name, and then my table again defining the format as delta, overwriting and saving the table as it is, right? So this way you can also create those, you can do, there are different transformations that you can apply.
Can you please share all these code and
These
and
are,
table also, I mean,
yes.
data set.
I'll share you these files as well as the codes. Although these are very basic things, but we have to start with the basics itself. So similar way, we have to when we are doing some sort of hands-on only, we'll get to know all those things, right? We'll get some errors. If you are getting errors, means you have to remove that error and understand that how we have to
As
remove.
for the understanding, what else we have completed, what kinds of transformation, so I can check on it. That's why I'm asking
Yes.
about it.
So transformations, as I already told you last time, basically in Spark we have got two types of transformations are there. One is my like basically transformations are also going to be of two types. This is again interview question is there. Generally this question is going to be asked. So if we have got first we have got transformations. So transformations can be of two types. One is by narrow, and another one is going to be my wide transformations. So narrow transformations are those transformations where my data is not going to be shuffled, no shuffling. Like my data is in different even it is in the different partitions, by no shuffling is going to be, let's say I have to do filtering, I'm doing some sort of filtering, I'm doing
Image like pivot and pivot.
yes. So like wherever the no shuffling of data is required, we generally call them narrow functions, narrow transformations. Another is wide transformations are there where the shuffling is going to be there. So shuffling is generally going to be happen when we are doing, let's say, group by. group by functions, join we are going to do.
Okay.
So wherever multiple partitions are required to do the any transformation. So why transformations are they are very cost consuming things. So generally we have to optimize them, right?
Hmm.
So in when we are, this is related to how we deal with this transformation. But if I talk about the functions, so let's go and transformation functions. For transformations and action functions. So basically, there are basically total 80 different transformation and action functions are there. So as I told you, like Spark is lazy optimization, right?
Hmm.
And unless we are not going to hit any of these actions, my actual crossing is not going to happen. That's why it's called lazy evaluation. Only a DAG is going to be created. So narrow transformation like filter, map, union, so they don't need any sort of redistribution of your data. So only within the partition itself, everything is going to work. So wide transformations, as I told you, it's going to be group by, join, distinct, because distinct is going to be work. Like say my data is in three different partitions are there. So first it has to group that data, and then it is going to do the distinct, right? Because there might be the case like uh, some duplicates are in partition 1, some are in 2, some are in 3. So until unless we are not going to group them and then going to do the distinction, then it will give us the again the duplicates. So examples like select, filter, map, these are all basically my narrow transformations, and then this is going to be my group by, join, or Y transformations. So generally in Y transformations, repartitioning means like we have to reshuffle the data again. Okay, so like collect, count, show, take, save as text file, reduce. These are all my action functions are there, right? So we, if we are going to hit any of these functions, only then my actual transformation will start. Otherwise, only a DAG like directed acyclic graph is going to be created, and then on the basis of that the plan is going to be created. So Spark basically, now the Spark is smart enough, and with the introduction of new libraries, new things introduced, Spark, like whatever, like if I talk about myself, like for 5 years down the line from now, I used to do the most of the transformations or the optimizations. I have to do it manually by writing the code. But now we have got AQE, adaptive query execution is there, which basically do lot of optimizations for us, like wherever it is required. So basically whenever the DAG is going to be created, so it automatically optimizes the plan. Basically it creates like let's say I have created a sequence of let's say this. I talk about this is although simple. Let's say mm, yes. So like let's say we are reading the file, then we are doing some sort of renaming, then filtering, and then finally I'm writing my data. So this is one set of the DAG is going to be created. So first I'm reading it, then doing some renaming, and then filtering. So these are all called transformations. So until unless I'm not going to, I'm not using a save as. So this is my action function. My actual DAG is not going to be, it's not going to be run. So within this itself, let's say if we have to do lot, transformation. So basically, what Spark does now is it creates the plan for this, different plans, like in, and then at the runtime it checks, okay, which is going to be my best plan. Best plans means like cost effective. Cost means time. Or if we are talking about the cost, like there are two types of plans: cost-based plans and role-based plans. So it basically takes the cost, in the sense cost here means the less amount of time it is going to take to process it. So it becomes that plan. So it creates 3 plans, 4 plans as per the requirement, and it picks the best plan. And how it is using it, like when we are reading the data or when we are writing the data, so how it is going to arrange that data so that it should always take the less time. So now Spark 3.0 onwards, they have come up with one optimization framework called AQE, adapted query execution. Means at the runtime it will see, okay, which plan is going to be better for this particular query, and based on that it will pick that plan and execute it. But before AQE, we have to do these transformations. Like if my we have to arrange, like let's say I'm having 10 different partitions are there. Although we'll talk about the partition in detail, but just partition is basically the grouping of the data. So generally how partition happens is, the best way is like whatever my data is there, divided by 128 or 256 MB. Like whatever data size you are having, let's say I'm having 1 GB, so divided by 128, so 8 partitions are going to be there by your system is going to be defined. But if you talk about like if you have not defined like anything, so what it does is it automatically creates default 200 partitions. Like even my file size is very less, and it will create 200 partitions. So although my data will be reside in one partition only, because it was even less than 128 MB, as here we are dealing with just a few partitions only. Our data size is quite less, but if we are going to do it on the on in the real times, or if, when we are working with huge large data sets, so it will do it that way. So partition basically is one of the most optimization technique that we have to apply. So in each and every project we have to do the partitions, because if the partitions are not correct, let's say one partition is having very less amount of data, another partition is having a very huge amount of data. So let's say I did the partition in 100, and my distribution of data is not correct. Like each and every partition doesn't have almost equal amount of data. Then the partitions which have less amount of data, they will run faster. But one partition which was having, let's say, more than one partition is having around 500, 600 MB, and the rest of the partitions all have less than 100 MB of data. So they will run faster, and that one partition is going to cost you a lot, because that partition will not going to complete. It will go in round and round, and so because of this, your job is going to be take longer time, or it will fail at the end. So it will consume your compute, and there is no use of it. So that's why we have to do the partitions very efficiently. And this repartitioning is if we are going to do let's say this is my final data frame is there, so I can do df transform baby names dot repartition. So with in repartition, basically we can increase or decrease the number of partitions. So as per our understanding, like what the data size was there, and how many number of records are there. So based on the number of records or the size, we can repartition our data and then reprocess. Then next time when we are going to process it, it will work fine. So in this way we can do a lot of optimizations. But now what I was telling is, like, these kind of optimizations generally done by the Spark itself, but it is not always 100% sure that this is going to done. So in some cases some skewness is going to be there. Skewness means like data skewness. This is another optimization problem which comes, like, so as I discussed, like some of the partitions having less data, some of the partitions having more data. So in that case we have to do apply one technique called sorting. So we just break the data in using some sort of temporary key, and then redistribute the data and then reprocess it. This way we can just remove those things. Okay, so this was all about this. So what I was trying to do today itself is like there is one airline uh, application is there which basically predicting whether the flight will arrive late based on the features like the months, airline times, what are the carriers, destinations, plane age. So using this, we have to build, this ingestion. So this is having a lot of, different files that it is going to use. So if you go here to catalog within the volume, test volume, I've uploaded these files. I'll share these files with you. So
Okay.
so these are like airport CSV, flights, small CSV, and plain CSV. These are the three input files are there, which are going to be used for this particular, small application. And then we are going to have a lot of, output. See what statistics it's going to be used. So here we are going to use some sort of machine learning models also, because we are going to predict it. So whenever we are predicting something, we have to use some sort of little machine learning. So we'll see how what are those going to be there. So we'll see all those things. You want to start it from today or what?
Let's do it tomorrow,
Yeah,
because before I wanted to try these queries
yeah,
little bit.
sure. Fine.
Yeah.
So we are going to do these. Here you will learn a lot of transformations that we are going to do, because every time if I'm going to tell you one by one, so what happens is like a lot of the things we those got skip off our mind. But when we are doing it, using the hands-on, so side by side you can also, like what we are doing is, when you have got the same data, your file, same files, you can run those in your system itself, and you will get to know, okay, what is the issue that you are getting. If you are getting any sort of issues, that we can fix those ones, right, at that same point of time, right? And you will get to know, okay, what
Yeah.
issues are there. So
Yes.
I'll share this airline project with you, and
Okay.
it is having all the the inputs as well as the code itself. So if you want, you can just go through it if you got the time, so that when we are going to do it, so you have got some sort of idea.
Definitely, I'll go through it, but
Hmm.
I prefer doing it from from the beginning, by directly by keeping you. So
Yeah,
that we can do. And before that, I wanted to try these kind of small transformations. So you
yeah,
showed.
yeah,
So,
sure.
yeah. So please share all those codes and then the
Yeah.
files.
I'll share everything with you.
Okay.
No.
Yes.